All right, so this is our review for MGF 1106, the final exam, part 1. In this video, we will review problems 1 through 23. All right, so for problem number 1, you want to express using set notation and the listing method, even whole numbers less than 12. So digits that are whole, remember that definition of whole numbers, that describes 0 and all positive whole numbers. So if we list all of these positive whole numbers that are less than 12 and are even numbers, we should have 0, 2, 4, 6, 8, and 10. We would not list the number 12. We want numbers that are less than 12. So that includes 0 and all the even numbers up to 10. For number 2, a committee of 8 congressmen. So we want to choose 8 congressmen from a group that has 9 Democrats and 4 Republicans. So first we want to choose how many options for Republicans we could have. So we're having our option of 4 Republicans, but we're only choosing 1. So this formula, the factorial formula we want to use for N, choose K. We have 4 Republicans to choose from. We're choosing 1. So our N, we would substitute 4 factorial in the numerator. In the denominator, K factorial, since we're choosing 1 at a time, our K is going to be 1 factorial in the denominator, and N minus K, or 4 minus 1 factorial. And when we simplify this, we'll just get 4 factorial. Now we'll multiply this result by the remaining congressmen. So if one of those congressmen is going to be Republican, of course, the other 7 would have to be Democrat. So that means we would be now choosing those 7 remaining positions from the 9 Democrats. So 9 choose 7. We're going to multiply both of these together. So we would use our same formula. Our N this time is 9. So we have 9 factorial in the numerator divided by our K is 7. So 7 factorial times 9 minus 7 factorial, or 2 factorial, okay? And then we want to simplify these two, multiply them together. When you plug these numbers into your calculator, you should get 4. It'll be 4 factorial, but I'm just going to simplify. Remember, you have 4 times 3 factorial here. In our denominator, we have 2, or 4 minus 1, which will also be 3 factorial. Those 3 factorials will cancel out, leaving 4. So 4 over 1 factorial just give us 4. Times 9 factorial. Again, this is going to simplify. We could simplify out that 7 factorial. So that'll be 9 times 8 times 7 factorial for the numerator. And then those 7 factorials can cancel with the numerator and denominator. Now this 2 in our denominator, that gives us 9 times 8, or 72. And then we divide that by our 2 in the denominator. So we have 9 times 8, or 72 in the numerator, divided by 2. That's going to give us 36. And 4 times 36 will give us our answer of how many arrangements. There are 144 ways to have exactly 1 Republican on the committee. For number 3, we want to let P represent I study. Let Q represent, this is an octopus, and then we're going to translate this symbolic statement into words. So remember that these symbols for that converse, we're using not P, that represents not P, and our up caret represents and. So that compound statement, we have not P and not Q. And remember, P stands for I study. Q stands for this is an octopus. So if we're saying not P, we're saying I don't study. That should be the beginning part of the statement. And not P, meaning this is not an octopus. So we want the statement that says both of those things. I do not study, and this is not an octopus, and that will be letter A. For number 4, we want to find the measure of each angle in this triangle. So remember our summation, all of the angles added together in a triangle sums up to 180. So we would create an equation for ourselves. We could add the measure of all of these angles together, and we know that that sum would have to be 180. So that's what we're going to do here. Take the top angle, angle B, which is 2x minus 118. And then we're going to add angle C, which is 1/2 x plus 10. And then we'd add angle A, which is x minus 20. Combine like terms here. So when we combine our like terms, we'll have 2x plus 1/2 x plus 1x. That'll give us 3.5 x or 3.5 x. So we're done with our x terms. And then we want to combine our integers. We have negative 118 plus 10 minus 20. And that'll give us negative 128. So minus 128 equals 180. We'll solve this two-step equation. We're going to add 128 to both sides and then divide by 3.5. So add 128 to both sides of the equation. We'll get 3.5x equals, over here, we'll have 308 for our angle, and then we want to divide that by 3.5. 3.5 can be divided evenly into x. So that'll give us an x value of 88. All right, so we'll get x equals 88. X equals 88. Once we obtain our x value, then we can go back and substitute to get the measure of each of the individual angles A, B, and C. So to find the measure of angle A is x minus 20, and remember x is 80, 88. So 88 minus 20 will give us the measure for angle X, or excuse me, angle A, which we'll list as 68 degrees. And then for angle B is equivalent to 2x minus 118. And remember, our x is 88. So here we'll multiply 2 times 88. We'll get 176 minus 118. And that would give us the measure of angle B, which is 58. And then for letter C, the value of angle C is 1/2 x. So that's 1/2 of that 88 degree angle, 1/2 x, 1/2 of 88 plus 10. And 1/2 of 88 is 44. So 44 plus 10, that'll give us the measure of angle C, which will be 54. So those are all of our measures, A, B, and C, 68, 58, and 54. For number 5, the given jar contains yellow, blue, and red balls. We see them labeled here, B for blue, Y for yellow, and R for red. And we want to know if we randomly chooses a ball, and we want to find the odds against this given event, which is to choose a red or yellow ball. So odds against choosing red or yellow, we want to make sure we simplify in lowest terms. So odds against choosing the red or yellow ball. All right, so our first box should contain the amount of balls that are not red. This would be the odds against. So not having red or yellow, we want to put that number in the first box. The second box would be our odds of actually getting red or yellow. So the odds of not getting red or yellow would be every ball that's not red or yellow. That would be the blue balls. So 1, 2, 3, 4, 5 should go in the first box. 5, 2, if we actually get red or yellow, we're going to count the red or yellow balls. So 1, 2, 3, 4, 5, 6. So our odds against getting red or yellow would be 5 to 6. For problem number 6, we want to look at this set right here. It has 3, 5, 7, 9, and 12, and we want to determine the amount of elements. So that N of B, that cardinal number, tells us how many elements are there in set B. So we just count these elements. There are 1, 2, 3, 4, 5. So the number of elements in set B would be 5. This is our answer. For number 7, determining whether we have convex or non-convex shape. Now we want to be mindful here of what it means to be convex or non-convex. I want to share this with you guys. Just go back to some of our notes. All right, so here is an example of convex and non-convex. Remember that convex means that any 2 points that you create and connect to draw a line inside of that shape, that line and all points on that line will be inside of the shape. So here is an example of a line that's drawn. We can put any 2 points inside this shape and connect those 2 points to create a line, and those lines will always be inside the shape. Therefore, this shape on the left is convex. Here we see 2 points that are inside the shape, but when we connect that line, not all of the points on that line lie within the shape. So this will be an example of non-convex. So let's go back to our problem. All right, so we see for our shape, if we draw 2 points in this line, we can connect these 2 points, and all of the points on that line will not lie within the shape. Therefore, this shape would be non-convex. For number 8, determine whether we have a permutation or combination. So let's go back to our notes again. Now, when determining if we have a permutation or combination, we can refer to this table. Permutations, we're selecting a particular item out of n items at a time. And for combinations, we do that same selection process. For both permutations and combinations, repetition is not allowed. Order is important for permutations, but order is not important for combinations. The arrangements are taken in items R at a time for permutations, and then subsets of n items are taken R at a time for combinations. We see our 2 formulas, factorial formulas we're using, and some clue words that we look for to determine if we're going to use the permutation formula are arrangements, schedule, and order. Clue words, if we're looking to find the combination, would be group, sample, or selection. When we go back to our question, we will see that we're being asked to find a hand of cards in poker. So we want to know whether or not order is important, whether the arrangements are taken or subsets of those arrangements are taken. All right, so in our problem, determining whether this is a permutation or combination, we have a hand of cards in poker. So the hand of cards that you're dealt in poker would be a combination, because repetition is not allowed. Either you're going to have one card or the other. You and the other players won't have the same identical card. There's one card represented in each set. And order does not matter. So you would choose combination, letter A. For number 9, find the value. We want to know the number of elements that are in A or B. If the number of elements in A are 9 and the number of elements in B are 13, and then the intersection, the number of elements that are in A and B is 8. We would use this formula to determine that value of the number of elements in A union B, so A or B. We would calculate the number of elements in A. We're going to add those number of elements that are in A to the number of elements that are in B. And we're given those values here. So A and B would be 9 plus 13. And then we subtract the number of elements that are in A and B. And that's also given to us as 8. So 9 plus 13 minus the 8, that'll be 22 minus 8. That'll give us 14 elements. For number 10, let P represent a true statement. So every time we see P, that represents a true statement. Q represents a false statement. So anytime we see Q, false statement. Now, here we have not back to back. So if we look at our brackets first, we're saying not P, meaning not a true statement. P is a true statement, but we have not in front of it. So not a true statement, or Q being that false statement, so false statement or true statement. So here we see our contradiction. If we're looking for the truth value, is this true or false? It can't be either, it can't be both. It's either true or false. And because we're writing this line in front of it saying not true, and then truth again, that negates that statement and makes it a false statement. So we're saying not true or a false statement or a true statement. So it can't be truth and false at the same time. So therefore, we would say that this is not a true statement. For problem number 11, finding the supplement. So that term supplement is two angles that add up to 180 degrees. So to find the supplement of a 78-degree angle, we just subtract 78 from 180, and that would give us the supplement. So 102 would be the supplement of a 78-degree angle. For number 12, we have this Venn diagram with letters M, B, and H. They represent these composers, these classical music composers. There are 65 students that were polled, and these are the results. So 38 of them liked our Mozart and Beethoven. All right, so 38 of them shared that commonality. 37 liked Ludwig and Beethoven, 30 liked Franz, and 16 like Mozart and Beethoven, 21 like Mozart and Haydn, and 14 like Beethoven and Haydn. 9 liked all three of the composers, and this is going to be your starting point. Since 9 of those students liked all three, right here, letter V would be represented by 9. And that will be our starting point. From there, we're going to fill in the rest of our circles. Okay, I'm going to start with the Mozart, the letter M. Now, if I know 9 of the students shared all three combinations, I'm going to take 9 away from the students that liked Mozart and Beethoven. So up here, we have our amount of students that like Mozart and Beethoven, 16 of them. So we're going to take that 16 and we're going to subtract 9 from it to determine what T would be. 16 minus 9. And so letter T, we have it labeled down here, should be 7. Next, we're going to fill in the circle for W, the section right here for W. And that would be the students that liked Mozart and Haydn. So that value is 21 given to us. So we're going to subtract 9 from the 21. So 21 minus the 9 will give us the value for W, which will be 12. All right. Now I've completed most of my Mozart circle. I just need to figure out what the S value is. Since we know that given to us at the beginning that 38 students like Mozart, we know that that whole circle should add up to 38. So we're going to take our 38 and we're going to subtract 7 for T. So subtract T, subtract 7, and then subtract from that number the 9 that was shared, and then subtract the 12. That'll give us our value for S, which will be 10. Okay, so we have that section. The Mozart circle is complete. Now let's look at the Beethoven circle. We already have values for S and for V to get our value for X next. All right, so X is that shared section of the students who like Beethoven and Haydn. So the students that like Beethoven and Haydn were 14. We're going to take that 14 and subtract 9 from it. So 14 minus the 9. And that will give us our value of 5. Okay. Now to determine the U, this circle with letter B is all of the students that liked Beethoven. All right, and we were told that, let's see how many students, 37 students liked Beethoven and all. So we'll take that 37 because that's what all of these letters that are in the circle B should add up to 37. So to determine what U is, we got to subtract from that 37 the number 7, letter T's value, the number 9, which is letter V's value. And then we're also going to subtract down here the number 5. All right, and that'll give us our remaining values, letter U, which will be 16. Okay, so we've completed the Mozart circle, the Beethoven circle, and now let's look at the Haydn circle. So we've completed the W, the V, and the X already for this section. We just need to determine how many students in all like Haydn, and that's given to us in our directions. Up here, we had 30 students that like Haydn. So we'll take that 30 and subtract from it 12 minus 9, the V value, and then minus 5. Okay, and that'll give us 4 students in this section of the circle. Okay, let's remove some of these operators here. Here we've completed these sections of the circle. And the last letter V, this would be the students that didn't choose either of these composers. Remember, there were 65 students that were polled in all. So we take that 65 and we're going to subtract all of these values that are contained in the circle. What's left over would be the number of students that didn't choose either composer. So we'll take 65 and subtract 10, just going through the circle, subtract 12, subtract 9, subtract 7, subtract 16 and 5, and then subtract 4. So we'll, after we subtract all of these numbers from 65, we'll get 2. So down here, the number of students that didn't choose either composer will be 2. Now, letter A says how many of these students liked exactly 2 of the composers. So we want to know all these sections in here that had exactly 2 composers that were chosen. So that would be this section here. That's those that chose Beethoven and Haydn. This section here with 12, and also this section with 7. We would not choose the 9 because remember, that's all 3. So we're going to add those numbers together. 7 plus 5 plus 12, and we get 24. Letter B, how many of the students liked exactly 1 composer? So those would be all of our numbers that are isolated here, letter U, letter S, and letter Y. So we'd add those together, 10 plus 16 plus 4 to get 30. Letter C, how many of the students like none of the composers? We've identified that value as being 2. How many of the students like Mozart, but neither Beethoven nor Haydn? So we like Mozart, but neither Beethoven or Haydn. All right, so those would be these students here that are listed in Mozart's circle, but have no shared components with Beethoven or Haydn. So that's 10 students. Letter E, how many of the students like Haydn? And exactly 1 of the other 2. So like in Haydn would be 4. Okay, let's erase some of these colors here. Put our 12 back. All right, so students that liked Hayden and exactly one of the other two. So that would be the values that are shared with Hayden and either Mozart or Beethoven. So 12 plus 5, that'll give us 17. And then letter F, how many of the students like no more than two of the composers? So that would be two or less. All the values that are two or less, that would be 0. So we would add 2 plus, so 2 or less. That would include 4, the ones that like Hayden only. 5, it would include 16, which represents those that like Beethoven only, as well as those that like Mozart and Beethoven. So 7 plus 10 plus 12. We'd add those together and also, get our sum together. So we add all of these together, we'll get 54 or 56 students that liked no more than 2 composers. So it should be every number except for that middle number, because this number represents the students that liked all 3. All right, number 13, when solving this kind of problem, you want to think about what you're being asked to do. So some notes to keep in mind: if you're changing a larger increment to a smaller increment, like if you're going from feet to inches, you want to multiply. If you're moving from a smaller increment to a larger increment, so let's say you're going from feet to miles, you want to divide. In our situation, we're changing from millimeters to centimeters. Millimeters are smaller than centimeters, so we're going from small to large. Therefore, we should be dividing. Now, how much do we divide would be predicated on how many spaces we have to move. Each space represents 10. So if I'm at millimeters, I'm here, and I'm moving from millimeters back to centimeters, that's 1 space. That represents 10. Therefore, we would take the 7.6 divide by 10, and we'll get our answer. So 7.6 divided by 10, that'll give us 0.76 centimeters. For number 14, find the volume and the surface area of this sphere. Our radius is going to be 13 because we're given the diameter. And remember, the diameter runs all the way across the center of the circle from endpoint to endpoint. So this diameter is 26. Half of the diameter is going to be our radius. So we just take 1/2 of 26, and that's how we get our radius of 13 feet. We're going to use R equals 13 for our volume formula and also our surface area formula. So we're just substituting for the volume. We have 4/3 pi, we're substituting 3.14 times our radius cubed, so 13 to the 3rd power. You want to make that calculation first. 13 to the 3rd power. Make sure you put those exponents in there first. 13 to the 3rd power times 3.14, and then times 4. We want to divide that product, all of those multiples together, all these numbers multiplied together by 3. And when we do those operations in our calculators, we should get a volume of 9,198. And our units for volume is going to be feet to the 3rd power, so cubic feet. For the surface area formula, all right, for our surface area formula, we have 4 pi r squared. Also, our directions tell us to round to the nearest hundredth, so be sure to add 2 places after the decimal point. That'll be the hundredth space. So we should have 9,198.11 cubic feet for the volume. For the surface area, we want to round to the nearest hundredth as well. We're going to multiply 4 times 3.14, which we're substituting for pi, times our radius squared. Remember, our radius is 13. And that's where we want to start. Square 13 to the 2nd power times 3.14 times 4. And this time we'll get 2,122.64. And our units would be feet to the second power, so square feet. For number 15, we want to construct this truth table here. So we're putting either true or false in each of these spaces. Our statement here, we have P and not Q or R. So starting our truth table with each of our elements, we listed P, Q, and R. Then we listed not Q. We listed that combination of Q, not Q or R, and then the entire compound statement. So P and not Q or R. So if P is true, Q is true, this first row, and R is true, would not Q be true? And that won't be, because we've already said Q is true, therefore it can't also be false at the same time. Now going across that category, that first row here, not Q was not true, but it says or R. So R was true. So it could be either or, either not Q or R. And since R is true, we would place truth here. So now in the the last column of this row, we see P and this compound statement here of not Q or R, or either of these have to both be true. Is P true? Yes. Is not Q or R true? Yes. So since both of these are true, we would say true in the last column. And now we'll complete the rest of the truth table. So P is true, Q is true, therefore not Q would be false. Going down this row. So Q is false, therefore not Q would be true. Continuing. Q is false, therefore not Q would be true again. We move down. Q is true, therefore not Q would be false. Q is true, therefore not Q would be false again. Q is false, so not Q would be true. Q is false, not Q would be true. Now completing our fifth column here, not Q or R. So we're looking for either of these being true statements, not Q being true or the R column being true. So this time, neither of those are true. So we're going to say false here. Both are true. So we would say true. One is true. The not Q is true. Therefore, we would still say true. One of them is true again in the next row. So we would say true. Neither of them are true. So false and false means that this will be false. True and true, again, true. And then now one of these are true. So we would say true. Now we're looking for P being true and the column for not Q or R being true. So we need both of these to be true. The first column as well as our fourth column being true. So here we have two trues for the first row, true and false. So this will be false. Remember, both have to be true. So true and true, that will be true. True and true, again, this will be true. True and false, so this will be false for number 15. False and false, so we should have false. And then false and true. So we should have false. Remember, both have to be true. True and false, this will be false. Now we've completed our truth table for number 15. For number 16, find the number of distinguishable arrangements. Remember that term arrangements lets us know that we're going to be looking for a combination here of the letters in this word. So we got heebie-jeebie. Now we need to determine how many of these letters repeat themselves. There are lots of letter E's. We have 1, 2, 3, 4, 5, 6 letter E's. We have two letter I's. We have two of them. And we also have the letters B that repeat themselves. So we have two of those. Now, to determine the number of distinguishable arrangements, we have to find a combination here. Actually, when we go back to our notes, we're looking for the arrangement. So we're going to be determining our permutation using our permutation formula. All right, based on the number of letters we have, we would make this calculation. So let's go back to our problem, but using our permutation formula for arrangement. So we're taking the permutation of our 13 letters. All of those letters we count up, heebie-jeebie, we'll have 13 letters. So 13 factorial divided by those repeats that we listed here. 6 factorial for the E's that are repeated, 2 factorial for the letter I's, and 2 factorial again for those letter B's that are repeated. So in your calculator, you want to just use parentheses, show that division of 13 factorial divided by 6 factorial times 2 factorial and 2 factorial. You should get, once you punch that in, 2,162,160 distinguishable arrangements. This is how many arrangements you'll have for these letters that are in heebie-jeebies. Number 17, select either we have a component of or it's not a component of. Now, when we look at our statement, we have in one set 2 and 5. We want to know if 2 and 5 are a component or element of this other set that has 5, 1, 0, 9, 10, and 12. And we notice that 2 is in that set to the right, and 5 is also in this set. Therefore, we would say yes, 2 and 5, they are elements of the second set. For number 18, this graph here shows the government's receipts when we're given this budget from 1991 to 2001, and these are the receipts of what happened and what was spent in billions of dollars. So we want to know, when we're looking at this graph and we're looking at the shifts in the lines, the changes that occur in the line, when did it appear that there was a higher climb from the receipts to the outlays? The solid line, this blue line, the lighter line represents receipts, and this darker line represents outlay. So we want to know, when does our receipts line, the lighter line, appear to have a sharper increase, a higher climb, which means it's steeper than the darker line? So when is this lighter line having a higher line? So we've already put these points in here. At this point, from 95 to 96, we see this line appears to be more steeper, which indicates a higher or a faster climb than the line that's above it. Again, we see a steeper climb than the line that's above it. And then out here at this point in 2001, there appears to be a steeper incline than the line that's above it, where the climb is faster. So we're looking for each of these years represented: 95, 96, 97, and 2001. 95, 96, 97, and 2001, it will be letter B. For number 19, we have set U, which has these numbers 1 through 7. Set A, which has 2, 4, 5, and 6, set B, and we want to find the elements that are a complement of A and also a complement of B. So remember, this is the intersection of those. So let's list the elements that are in each of these sets. So complement of set A would be those elements that are not in set A. They're in the union, but they're not included in set A. So we would eliminate all of the elements that are in A, which would be 2, 4, 5, and 6. All of the other elements that's left over are 1, 3, and 7. Now, for the complement of set B, those will be all of the elements that are included in the union, but are not in set B. So the 4 we would remove, the 5, which we've removed, and 7. So all the elements that are left over would be 1, 2, and 3. As well as 6. Now, which of these elements are shared among both of these? We see 1 in both sets. We see 3 in both sets. All right, so that will be our answer. The elements that are in the complement of A and the complement of B are 1 and 3. For number 19, we have another Venn diagram we're working with, a middle school counselor attempting to correlate school performance based on interests. So we have 33 that had seen movie A, 33 students in all, meaning all of these S, W, V, and T should add up to be 33. We have 29 that saw movie B, which means again, T, V, X, and U should add up to 29. And then we have 26 that saw movie C. 16 saw movie A and B. So here, letter T, those values in T, those should add up to 16. 12 saw A and C. So here where we have the shared section between A and C, that should add up to 12. 11 saw B and C, so these two should add up to 11. 4 saw all 3, so remember that's going to be your starting point right here. Letter V, the number of students that saw all 3, and 6 students saw none of the movies. So down here, we're being given the value of Z as 6. 6 saw none of those 3, so it's outside of these 3 circles. Now let's continue to fill in the rest of our Venn diagram. Now first, let's look at section that's labeled T. This section is the students that saw A and B, but from that section, we need to subtract the 4 that saw all 3 of them. So we would take our 16 and subtract 4. That'll give us letter T, which is 12. And then letter X, we have here the number of students that saw both letters C and B, but we're going to subtract from it those that saw all 3 of the movies. So we'll take our 11 and subtract from it the 4 students that saw all 3. Okay, that'll leave us with 7 here for letter X. And then for letter W, we have 12 that saw both A and C, but we're going to subtract from it the students that saw all 3 of the films. So 12 minus the 4 would make W letter number 8. So let's go ahead and check those off. 8, our T, and our X. And now let's look at those that saw letter C, movie C only. So movie C, we know that in all there were 26 students that saw, so that means when we add up the X, the V, the W, and the Y, it should equal 26. But to determine what letter Y is, we're going to subtract 8, 4, and 7. So subtract from the 26, minus the 4, minus the 8, and minus the 7. And that's going to give us 7 students that saw movie C only. Now for movie B only, we know that together the 12, the T, the 4, the X, and the U has to add up to 29 students. We're going to take away the 12 students that saw movies A and B, the 4 students that saw all 4 of the movies, and then the 7 students that saw movies B and C. And that'll give us the students that saw B only, which would be 6. And then the students that saw letter A only, letter S, we know 33 in all saw movie A. We're going to take away the students that saw A and B. So 33 minus the 12, minus the 4 students that saw all 3 movies, minus the 8 students that saw movies A and C. That'll give us 9 students here. Okay, so we've completed all of these sections. B was given to us, and then Z was also given to us. Now, how many students saw movie C only? That would be given to us right here with letter Y, so it'd be 7. How many students saw exactly 2 of the films? So the students that saw exactly 2 films will be the 8 that saw A and C, the 7 that saw B and C, and then the 12 that saw A and B. So we would add those together, 8 plus 12 plus 7. And that'll give us 27. How many students were surveyed in all? We would add all of these numbers together in our Venn diagram. How many students were surveyed? So that should be even the students that did not see either of the movies. So 6 plus 7, we're just adding up all of the numbers in our Venn diagram, plus 8 plus 7, plus 4, plus 6 plus 12. We have 6, 12, and then 9. Okay, and that'll give us our total 59. For number 21, let P represent the statement, I get an A. Q represents the taxes are high. We want to translate this into symbolic form. So here we have not P and not Q. So not getting an A and the taxes are not high. So I did not get an A and the taxes are not high is the statement that I'm looking for. So yes, that would be letter A. Not getting an A and the taxes are not high. For 22, construct a tree diagram. So we want to know all the possible ways that when we toss 3 coins, that we get at least 2 tails. So we're tossing 3 coins. This would be considered toss 1, toss 2, and then toss 3. We could toss our coin and get either heads or tails. So here we start our tree. Now, when we toss that coin the second time, if it landed on heads, we could then, the second time, get either heads or tails. The third toss, we get toss and get heads first and then get heads or tails. So from each tree branch, we can get either heads or tails again for the third toss, heads or tails, heads or tails. When we carry each of these options to create our outcomes in the last column, we see we get heads, heads, heads for the first one, or we could get heads, heads, tails. We could get head, head, head again down here, or I'm sorry, we should get head, tail, tail. Want to list that one here. And then if we got tails first, tails, head, head, we could get that combination. We could get tails, heads, tails. We could get tails, tails, heads, or tails, tails, tails. So from these list of outcomes, we want to know how many have at least 2 tails. And that would be 1 here. So underline that. 1 here, 1 here. So there are 4 of them that have at least 2 tails. So it's letter B should be the correct tree diagram, and then letter D, which shows those 4 different outcomes that have at least 2 tails. For 23, decide whether this is a compound statement. Remember, a compound statement has 2 or more statements. This says the car is old. That's one statement, but it's not compound. It doesn't have 2 or more statements, so we would choose not compound. This is the first half of your final exam review.